طيب بسم الله الرحمن الرحيم. Again, welcome to our course. Yesterday we talked about, generally speaking, how to reason about the correctness of parallel programs, and we take one example of mutual exclusion. There are many examples in the chapter, but I think one is enough for us to grasp the idea. So today, let's move forward. And today we are going to talk about memory models again. So we are going to revisit consistency and coherence and so on, but this time from the point of view of software. And more specifically, Java. So here we are going to talk about the object memory models. By object, so basically, usually in hardware, you're very much like you are very much like usually the hardware is very much similar to programming in C. You have very level access, so you have memory, right? And memory usually is viewed as just flat array of flat memory space, or just an array. So memory looks as if you have a big array, and you can read and write to elements of this array, and that's it. Right. In Java, and more like programmer-friendly and nice languages, usually people like to use object-oriented programming. And in object-oriented programming, in pure object-oriented programming, you don't see memory at all. All you see is objects. Okay, so you don't say allocate an array of whatever. Of course, you can use arrays, but you are treating the array as an object, not memory. So if you want to make a buffer, you make a buffer object. Right? You can't say like I want to access this specific address inside the buffer. But in C, if you have an array, for instance, let's say you have a buffer, so you use like that, character. Right, character, buffer, something like that. And maybe buffer is 128 elements. And then you can do something like, maybe a pointer P, and then you can easily say something like P equal buffer, whatever. Yes? And you can do things like buffer plus equal, I don't know, 10, or maybe you can make a loop here. So you can actually address directly any location you like inside the buffer here. Right. So if you just use buffer without any attribute, you got the address of the first element. Whereas in object-oriented programming, you don't get that. You have a buffer. And the buffer, you can only access it via operators. So, so if in object-oriented programming, maybe you can do the same, you can have something like that. This is an array. Actually, it doesn't work like that, I think. It's, how do you do it in Java? Yes. New. But here you have something maybe like that? I don't know. Yeah, something like that, yes. And then you say new character. That's how you can change, yes. Yeah, so basically you say, like, this is a reference. Usually it's called a reference. It's not a pointer. You can't just do pointer arithmetic on this. You don't. Because in low level, what you have here is just you have a reference, or maybe it's called the handle. Yeah. So basically, if you look at lower level code, you'll find out that buffer would just be buffer probably would be an array type. Okay, so this is a local variable. Yeah, Okay, so I think, okay, so you're going to see this buffer as like local variable. Usually this is called like L0 and 1 and so on. Maybe let's say it's L5 for some reason. Right, so if you want to translate this into low-level code, you are going to find it something like something like that. Push constant 128 on the stack, right? And of course, it's not called I push whatever. It's just pseudocode, yeah. Right. It's not proper Java. Okay. This is the Java machine language. If it's popular, it's not machine language. It's called bytecode, right? Just sorry, I was running. Okay. So Java, you have a high-level program which is not Java, and what you do, you translate this into something else called bytecode. Yes. And then the bytecode you run on top of what's called virtual machine. Right. So here I'm talking about the bytecode, the Java bytecode. So what happens if you have something like that? You get translated into something like that. So you push the constant in there, and you have something like invoke, which is called further the method maybe car. So actually here the character is somehow encoded, yeah, just the name. And then this invoke will create an object of character array and so on, and return a reference to this object, or how do you call it? Yeah, just an index ID or whatever. And then you have something like pop L5. So basically, you put the constant, this one, you call this function will create an object for you and initialize it by calling the initializer, and will return some reference to this one that we stored there. This reference can be just a number, ID, handle, whatever, not necessarily a pointer to memory. And in Java, you can't do anything like pointer or arithmetic like that. It's not there. So the concept of accessing memory like C is not possible. You can't get just the address of buffer. You can't. It's just the name, ID, as it's buffer, but you don't know where it is in memory. And therefore, you can see your memory usually as a big heap structure. You can create objects. So usually, maybe in lower level implementation, usually you have something called heap, and in this heap you have objects. So what you do is you allocate these objects in the heap. But this is transparent to the programmer, it doesn't see what's in there. All you see is objects. Okay. And usually there were many ideas in the past. I think there was something, if you're interested, called the mushroom project, or mushroom hardware, whatever. And what they did, they actually built a hardware that works on objects. So you have object caches and so on. Anyway, so let's go back. So here, if you are programming in Java-like languages, the question is, how would memory models affect you? So this is what we're going to discuss here. Just only a few slides. Right. So we are going to quickly tell you how to write parallel program in Java, because most of the book here and exercises you'll find that they are in Java, and they are very nice. Java is a nice language. We are going to talk about what we talked about before, about sequential consistency, but here using objects. Right? So we talk about what's a sequential object, what's sequential consistency again, and something else called quiescent consistency, and something very strong called linearizability. Briefly we talk about it, but maybe if we have time we'll go in more details, or maybe next week. Right? And actually this linearizability is something which was invented by the authors of this book. It's very strong. Right, so if you want to write a parallel program in Java, this is basically like a template, is what you do. So this is hello world. Basically, you want to create, I don't know, many parallel threads, and each one would say hello, hello, hello. Right, so how do you do that? You have an interface called run, and your thread would be represented by a class with any name you like that implements the runnable interface. And because it implements the runnable interface, it should provide a function called run. Actually, this is the main function that runs from the thread. So your thread is represented as an object, in this case called arrow thread. You can have any functions as much methods as you like, but you need to at least implement run. So run will do something. So basically the system, as we're going to see, when you create your threads, it will invoke the run, and you can put anything you like here. So run can call others methods. It's like your entry point. So in this case, it will system.out.println is basically a print statement. This is how you print, and then message. And message, as you see, is a variable here, or a field. Usually it's called a field in Java, a class field or object field. It's called message of type string. String is an object. And you have a constructor. The constructor will take whatever string and will assign it to your local field or class field or object field. And you also need to know how to create. Yeah, here we go. This is the whole program. So this is like your serial program, the start of your program. You have your main function, so you create a class. It has to be class. So it's hello, public, okay, because it has to be like that. And you need to have a static method called main. This will be the entry point of your program. It takes string, it throws exception if something goes wrong. Some count, okay, 100. So actually this is the number of threads you want to create. Right. Final, I think it means like this, the constant. You can't change the value. Right. Integer I. And then what you do is you create an array of threads. Right. So you have something here called thread. Okay. So thread, I think this is a built-in type in Java. Right. So you create an array of threads. Thread. Okay. So it's an array. You create 100 objects or 100 thread options. Print starting. And then you make a loop, so you iterate. You change your I from 0 to keep count -1. And what you do, okay, you set your string hello and plus I, so this is concatenation operation. So basically, you have hello space 0, hello space 1, hello space 2, hello space 3, and so on. Right, so basically, you take this message and initialize a corresponding thread. So this is how you do it. So the object number I, this array. So this is an array of threads. So every entry is a thread. Right? And this new would create the array, but not the entries. So in order to create the entries, you create here another thread object, and as initializer, you create your hello thread that implements runnable in there. So you initialize this thread on your hello thread, and then you just invoke start. So start will in parallel fork the thread and run its run method, and then continue the loop. Of course, yes. So yeah, you have here just one thread control, and then when it reaches here, now there is a fork, so you have another thread. So maybe I don't know, we'll call this maybe main thread, I don't know. Then here you have like maybe thread 0 or some other one. Yeah. Okay, so let's do the other iteration. So the next iteration, you're going to have hello 1, then thread 1, you create a new thread with a message hello 1, and then you start. So in the second iteration, you start another thread, you have T1. And so on, until you have T99. So you have 100 threads plus main thread, so 101 threads. And then the main thread would run this loop. This loop would wait, so like 0 changes, I change from 0 to t count -1. And basically, the main one would wait for the first thread to join, so it will block. It will wait until this one finishes execution, and then it will join and return. So you return the second one until you've destroyed, finished. It's exit, the thread is finished. Until 99, and then it will start or exit. So as you see, this is a shared memory model. And as you see, there is no explicit use of memory. You can only access objects, variables, and so on. Okay? But yes, they should be in memory somewhere. Yes, they don't have direct control, but they are in memory. So they are still shared memory. But maybe a more accurate term would be like shared objects. Of course there is. If you look at the API, you find locks and everything. And actually there is something, maybe we talk about it here. There is something called synchronized. Yeah. Actually Java uses what's called as monitors. Maybe we'll talk about it here. Let's see. So if you, before your function, put the word synchronized, so this means that this is like mutual exclusive, so only one can access this method at a time. And you can have synchronized blocks. Yeah, so actually Java uses what's called as monitors. And a monitor basically, yeah, I think it's next slide. If it's not there, I'll explain. Okay, let's continue the slides, and then we'll see. But this is like basic hello world program. This is how you do it in Java. So you can easily do this by downloading a Java runtime environment or Java SDK. Actually, you can get the Sun, now it's Oracle. So if you search on the website for Oracle, you'll find the latest Java SDK, you can download it. Sorry? Yeah, of course, yes. So download the latest.
How's the performance of the program will be affected by the business?
Should be better. Of course, there is some overheads to create the threads, but if you have what's called as a core screen, so every thread is doing lots of work, then this overhead of creating the thread should be minimal, negligible. So usually in Java, you are, as we call it, heavy threads. You have to do lots of work. You can't just say, I'm going to create a thread just to add two numbers. It's not a good idea.
But I have to be sure that the threads are independent.
Not necessarily independent. Okay, you can synchronize. You can make synchronization points. We are going to talk about synchronization and so on. Yes, of course. You can just put here some, you can search, I can't remember how you do it, but something like get time, whatever here. And when you finish that time, you subtract them together. Okay, yes, monitors. Good. So actually, okay, the way synchronization is handled in Java is via monitors. Right, so what's a monitor? Okay, a monitor, maybe we can do some diagram here, it will be easier. I should have drawn you something. Right, imagine that you have a room. So this is your entrance, and this is your exit. Okay? And I think this room is, you can say this is a specific object or class. So this room, you can have visitors going inside this room. Fine. The condition you have is that if maybe this is A, so if A goes here and B comes here, right? So B can't enter because A is already inside. Right. So B has to wait outside. Okay, just like a lock. Fine. However, A can work inside and then go to the fridge and freezes himself inside the room. So he goes here to a deep freezer, right? And goes inside there and sleeps. This is A. Right? Okay. He can wait for some condition. Okay, it's called sleeps or waits. On some condition. Okay. Now, B enters the room and works. Fine. Right. Now, B decided that he finished his work and one is leaving the room. Right. So basically, maybe, okay, in your program you know that now B has finished the work that A is waiting on. So actually B here will call notify, which is a method here inside this object. So to invoke notify. So notify this one or maybe notify all. So notify all would say, okay, maybe I have many people sleeping here in many deep freezers here. So notify all is like wake everyone up, but not now. Right? When exit. Okay. So when B exits the room, notify becomes active, and everyone wakes up. Right? Now, again, right now, okay, everybody wakes up, but very good. Right. So when you wake up, it is as if you are wake up and you're thrown outside the room. Right. So you come here. So this is straight A, whatever, and so on. So you wake up and go outside the room. And then you try to enter the room again. Right. If you can enter, then it's fine. If you can't, then you can sleep again. So this should be something like, okay, so you either enter the room or just go there directly to fridge and sleep. So basically, this is what happens. Wait. So if you invoke wait, you sleep. Right. Right. I'm not sure what this notify one. I need to check the internet. Because here, what I written here is it wakes, it acquires the lock again. So when you wake up, this means that you're already inside the room. Yeah. But then notify all. Let's check it after we finish it. Just remind me. I'm not sure you also notify all. So just let's say normal notify. So normal notify is like that. You just when you exit, you notify this guy that you finished. So this guy wakes up and he's already inside the room and continues work. Okay. I'm not sure what notify or maybe notify you go outside. I'm not sure. Actually, check it. Then you have the yield. Yield, basically, you can say, right, okay, maybe this is not a monitor, but it's something like, okay, I am running now, but I am not really doing anything useful. So I can be deallocated from the processor. So this is like I can be scheduled out. So I can leave the processor to others. I'm not doing something very important. So I'm happy if you don't, you know, the system decides to stop this right now or pre-schedule it now. So we use it. Maybe I describe notify all. see it here. I just want the API definition. Yeah, maybe this one. Yeah. Okay. Wake up a single thread that is waiting on the object monitor. Okay. Wakes up all threads that are waiting on this object monitor. But maybe they don't acquire the lock. Let's read in details. Right. The awaiting thread will not be able to proceed until the current thread relinquishes the lock on this object. The awaiting thread will compete in the usual manner with any other thread that might be active, competing synchronously with each other. For example, the awaiting thread enjoy no reliable privilege or disadvantage being the next thread to lock this object. This message should only be called by a thread that is the owner of the object monitor. If the notify method for this right. So okay, so it awakes all threads, but then they are going to compete to synchronize. So actually yes, so they wake up and they saw them outside the room. Yeah. So they are outside. So they can't enter the lock unless it's empty. So they're waiting outside. Right. But notify, let's check. Wakes single thread. The awakened thread will not be able to proceed until the current thread link. The awakened thread will compete again. The usual manner with other threads will be active compete. Right, so it's okay. So if you notify, you wake him and you throw him outside the room. And he has to enter through the door. So if someone else managed to go inside the room, then you have to wait outside. Not wait by calling wait, but you basically, okay, so you wake up, and then when you wake up, you try to enter the monitor. Right, so you have to try to enter the monitor. And when you enter the monitor, you can be blocked. So you're waiting for, okay, I'm waiting for my turn. Exactly. So this is the API. It's really, really nice. You should always refer to it. So this is Java. And of course there is the, I don't want to waste time, but if you're really deeply interested in Java, you'll find the specs. Yeah, the Java virtual machine specification. Yeah, this one. Where is the specification? Tools, Urban tools, this one documentation. Enhancement, parallel enhancement, garbage, yeah, enhancement. I don't know why it's not really easy to find documentation here. Actually, I haven't seen this site until when it was used for by Sun, yes, but Oracle changed things here. Right, so maybe it's here. Just how to invoke some enhancements, more information. Strange. Maybe you see Java, JVM spec. Yes, this one. Yeah, don't know. Well, it's not very easy to find, but anyway. Yeah. So this is if you're really interested to see how it works internally. This is what you should look for. For instance, the example I tried to show you about the push and invoke is here. So you can see something like maybe push. Yeah, where is push? Oh yeah, it's not called. I think it's called I constant or I something. Load maybe. Yeah, something like that. Reload, load. Yeah, we're not push, I think it's iLoad or constant load, something like that. Well, let's just check. No, there's no push, maybe load. It should be somewhere here. A-load, this is address load. There should be something called the iLoad. This one. Yeah. iLoad is the, no, this is not a constant. I think it's called maybe iconosm. Yeah, this is the iLoad, this is standard. This is like, okay, you're pushing a local variable. It's, but I think the other one's called iconostant, maybe. Completely forgot now. How it works. Nice. Right. Maybe pop. Maybe pop is the opposite, but. Pop is type safe validity, and this is how it works. Right. Yeah, I think they changed many things here. I mean, the way it's presented. Not find it. I push? What is that? Push type integer. Okay, so maybe it's the one here. So stack maybe. Yeah, so maybe it's the one, yes. Okay, good. Right, anyway, so this is like a complete spec of Java, but you know, this is just curiosity, but you're not required to look into detail. Right, so now, okay, let's have a pause for 2 minutes and then we'll continue and I transfer the video. Okay.